In this video, we're looking at problems involving arithmetic sequences. So we have some problems for you to look at. 4 problems here. You want to pause the video and try these, and then I'll come back and work these out for you. Okay, just to brief review before we get started. A sequence in general is a function whose domain is normally the set of counting numbers or the set of positive integers. Sometimes it could be a subset of that, but most of the time the domain will be the set of positive integers, starting with 1, 2, and so on. We can also say that given the first term of a sequence, and here we're looking at arithmetic sequences as opposed to geometric sequences, each number after the first is obtained by adding the same value to the preceding term. So the set of counting numbers, for example, you list those as a sequence, 1, 2, 3, 4, 5, and so on. The difference between consecutive numbers of the sequence is the same. In this case, the difference for any consecutive integers is 1. Now, some of the problems will ask you to find a particular term of the sequence. Later on, they could ask you to find the sum of the first n terms, for example, the first 100 terms, and so on. So let's look at your basic formulas that you have. The nth term of the arithmetic sequence is given by a sub n. A1 is the first term. D is the common difference. So I look at the sequence, say 3, 6, 9, and so on. The pattern continues. You can see that we go 3 and then we add 3 to get 6, add 3 to get 9. So the common difference between any two consecutive values of the sequence is, in this case, is 3. So we would say D, or the common difference, is 3. The first term is 3. And this is your formula to find a particular term of the sequence. These last two, you want to find, say, the sum of the first n terms of an arithmetic sequence. So notice the first formula, it's the number of terms n divided by 2, and then it's 2a1 plus n minus 1d, where d is the common difference. But notice that if I break this into, say, a1 plus a1, because that's 2a1. But if I put this a1 with this part right here, then it gives me a1 plus n minus 1d, which of course is this. So that's why I can write that formula like this. So I have two formulas for finding the sum of the first n terms of an arithmetic sequence. Okay, so I hope that's a quick review for you, and it's enough. Let's go now and look at the first problem. Find the 100th term of the arithmetic sequence 2, 6, 2, 4, 6, and so on. So let's give the information we have then. The first term of the sequence, you can see, is 2. And notice we're just adding 2 to the previous number to get the next one. So the common difference is 2. So now it wants the 100th term. Now, I could go ahead and list them all and just say 2, 4, 6, 8, 10, 12, and keep on going until I count 100 terms and then find out what that is and put it down. But with the formula, a sub n, and here n is 100, I want the 100th term, and according to the formula we just looked at, it's a1 plus n minus 1d. D is a common difference, and here the first term is 2, so it's 2 plus, and then it's n minus 1. Well, here n is 100, so subtract 1 from that, it's 99. Times d. D is the common difference is 2, so we get this. And then 2 times 99 is 198, and 2 gives me 200. So that's the answer. Let's go to the next one. Now this tells me the first term, or find the first term and common difference of the arithmetic sequence with 12th term of 4 and 18th term of 28. Give a formula of the nth term. So now, using the formula for the nth term, in general, the 12th term, or A12, will be given by the first term. We don't know that yet, that's what we're trying to find. The first term plus n minus 1, in this case n is 12, so this will be 11, times the common difference. That's what we're looking for also. And now we also know something about the 18th term, so I can say A of 18, again, is equal to whatever the first term is. We're trying to find that. So let's just put A1. For the first term, we're using A1, plus n minus 1. Okay, for this one, n is 18, so subtract 1 from that, that's 17, and we get the common difference, is D. Okay, so now we're just worried about this now. We set up actually a system of equations here. So we're just interested in the first right side of each of these, A1 plus 11D and A1 plus 17D. And we know that the 12th term is equal to 4. So that's how I get my equation, equal to 4. And the 18th term is 28. So to solve this problem, basically you just have to go through and solve a system of equations. So it's a system of equations in the variables A1 and 11, and A1 and D. So let's just eliminate. Let's do it by elimination. I'm going to multiply the first equation by minus 1. So that's minus 1A and A1. That cancels. I have a minus 11D and 17D. That's 6D. And then it's multiplied by minus 1. Minus 4 and 28 is 24. Solve for D here. We have 6D is equal to 24. So D is equal to 4. So the common difference is D. That's what part of what we're looking for. D is equal to 4. So now let's go back and substitute here. For the first equation, put it 4 where the D is. That's D. 4 times 11 is 44. Bring that over to the other side. That's negative 44. So A1, negative 44 and 4 is a negative 40. So say it's looking for the first term. This is A1, that's the first term, and the common difference. And then it also wants us to give a formula of the nth term. So for the nth term, the general formula is A sub n is equal to whatever A1 is, and in this case we found A1 to be negative 40, plus, and then it's n minus 1 D, common difference, which is 4. This is times 4. There's your formula. So if you wanted, say, the 200th term of this sequence, you would just take this formula, put a 200 where the n is. Here, 200 minus 9 times 4 at negative 40, you get that particular term. Okay. In the next one, we want to find the sum of the first 120 terms of the sequence. Find the sum of the first 120 terms of the sequence. And here it's given 14, 16, 18, 20. So I could do it the long way, and I could just keep going here. 14, 16, 18, 20, 22, 24, 28, and so on, until I count 120 terms, and then add those terms, those 120 terms manually, and you have the answer. But that's a little bit long to do that. Say you had 1,000 terms. You don't want to do that. You don't want to do it even with 120. So let's go look at the formulas that we have. This one here, S sub n, is it's the sum of the first n terms. And again, this is for an arithmetic sequence, which is what we have here. To use formula number 1, you need to know the first term, you need to know the number, you need to know n, or the number of terms, and you need to know the common difference. To use the second formula, we need the number of terms n, and we need the first and the last term. Well, we know the first term, but the last term is not given. So it's easier here to use this one right here. S sub 120 will equal to 120. That's n over 2, so it's 120 over 2. And then parentheses, it's 2. Using the first formula I pointed out there, is 2 times the first term. And the first term is 14. Plus, and it's n minus 1. Here n is 120, so this will be 119. Times d, for the common difference. We'll see that here the d is 2, because you're adding 2 every time to get the next one, so this is times 2. So then you do the calculations there. Use the calculator here. So in the parentheses then, it's 2 times 14 plus 119 times 2 is 266, and then let's multiply by 120 over 2, but 120 over 2 is 60, so this is times 60, so we get 15,960. That's the sum of the first 120 terms. Okay, on the next one, we want to find x so that x plus 3 and 2x plus 1 and 5x plus 2 are consecutive terms of an arithmetic sequence. We find the value of x that satisfies that condition. Well, that simply means that if I take 2x plus 1 and subtract x plus 3, 2x plus 1 subtract x plus 3, that should equal to the same difference from 5x plus 2 and 2x plus 1. So I take the difference of 5x plus 2 and subtract 2x plus 1. Those two differences should be equal. That's the definition of an arithmetic sequence. If you take any two consecutive terms and subtract, the difference or value will be the same. So here, let's just subtract this. This could be a minus x here, and a minus 3, so this will be x. And minus 3 and a 1, so minus 2. And then over here, 5x plus 2, subtract 2x plus 1. 5x, and then a minus 2x is 3x. Minus 1 and 2, that's a plus 1. Subtracting x from both sides. Cancels this x, and then x, 3x is 2x. Then add negative 1 to both sides. Negative 1 here would cancel that. Negative 1 and a negative 2 is a negative 3. Solve for x, so divide here by 2. So this would cancel here. So the value of x that satisfies that condition, or that statement, is x equal to negative 3/2. Thanks for watching. We'll see you next time.